So we have an algebra shape space measure question. Total surface area is 300 pi. So we've got to start off by writing out what we know surface area of an open tin. So that we'd say that it has a base but doesn't have a top. So the surface area of 300 pi will equal the base, pi r squared, and then the circle, the circular curved area. And if you remember from your GCSE, that is a rectangle if opened out. The base of the rectangle, 2 pi r, the circumference of the circle, and we have h for the height, so that is plus 2 pi r h. We're asked to express h in terms of r. So we have that 2 pi RH would equal 300 pi minus pi r squared. Going to divide everything by pi. 2RH equals 300 minus r squared, which means that h is 150 over r minus r squared over 2r, which is r over 2, or 1/2 r. There's many ways that you could present that final answer. So I have h equals 150 over r minus r over 2. You could have 150 over r minus 1/2 r, or you could have left it with a common denominator. Common denominator being 2r, and you have 300 minus r squared. So hence show that the volume is 150 pi r minus pi r cubed over 2. Don't focus on the final, what they're asking for. Let's write down what we know. Volume is cross-sectional area times height of a cylinder is pi r squared, multiplying that by height. Hence usually means you're using what went before. And for us, I got that height was 150 over r minus r over 2. So if we expand the brackets, that gives me 150 pi r squared over r, which cancels to give r, minus pi r cubed over 2. Remember, even if you weren't able to do parts 1 and 2, you can do part 3. So we're looking for a maximum, which tells me I want to differentiate. And if we differentiate 150 pi r, we get 150 pi. And if we differentiate r cubed, we get 3 r squared, bringing in the pi over 2. Maximums occur at turning points. So that's when the differential is equal to 0. And I'm going to divide 3 by 3 pi, which gives me that 50 minus r squared over 2 equals 0. Rearranging that, 50 equals r squared over 2, so r squared would equal 100, which means that the radius is 10. Now, be careful. Read the question. Find the values for r and h. So I have r. I need to go back and substitute in h. And h was 150 over r minus r over 2. So that is 15 minus 5. And we see that h was also 10. Now, there's always one last part to these questions. And now that we have worked out all of that, what we must do is prove that it's a maximum or a minimum. And we do that by finding the second differential. 150 pi differentiates to give 0, and 3 pi r squared over 2 will differentiate to give minus 6 pi r over 2, which is minus 3 pi r. When r equals 10, second differential will be minus 30 pi, which is less than 0. Therefore, it is a maximum.